In the last video, we have learned about different number system and how to represent it. Now we can learn how to convert one number from a number system to another number system. It is easy to convert numbers from one system to another number system. We have learned decimal number system, so we can convert decimal to octal, decimal to binary, and decimal to hexadecimal. In the same way, decimal fractions to octal, binary, and hexadecimal. Then binary to decimal, binary to octal, binary to hexadecimal, binary fractions to decimal, binary fractions to octal, and binary fractions to hexadecimal. Then from octal to binary, octal to decimal, octal to hexadecimal. Then octal fractions to binary, decimal, and hexadecimal. And at last, hexadecimal to binary, octal, decimal, and hexadecimal fractions to binary, octal, and decimal. It is easy to convert one number system to another number system. So first we are going to learn how to convert a decimal number to binary number system. That means from base 10 to we have to convert it into base 2. So first example is 25 base 10. I want to convert this decimal number to binary number. For that, we have to repeatedly divide 25 by 2 because we are converting decimal number to binary. So, we have to repeatedly divide 25 by 2. So, first I am dividing 25 by 2. When 25 is divided by 2, the quotient is 12. We have to write the quotient down here. After that, the remainder. Remainder is 1. We have to write the remainder in the side. Again, we have to divide 12 by 2. When 12 is divided by 2, the quotient is 6. We have to write the 6 here and the remainder 0 here. Again, we are dividing 6 by 2. So, we'll get the quotient as 3 and remainder as 0. We'll write the 3 here and 0 here. Again, we will divide 3 by 2. We will get the quotient as 1 and the remainder as 1. And we will write the remainder here. Now, it is not possible to divide 1 by 2. So, we can write the answer and we are writing the answer from bottom to top like this way. And we will write 1, 1, then 0, 0, 1, base 2. So, this is the binary equivalent of this decimal number. Now we can try the next example, that is 17. We have to convert the decimal number 17 to the binary number. For that, we have to repeatedly divide 17 by 2. We'll write 17 is divided by 2. We'll get the quotient as 8 and the remainder as 1. So we'll write the quotient 8 down here and remainder 1 in the side. Again, we will divide 8 by 2. The quotient is 4 and the remainder is 0. We will write the 0 inside. Again, we are dividing 4 by 2 because it is possible to divide 4 by 2. We will get 2 as the quotient and remainder as 0. Again, we can divide 2 by 2. So, the quotient is 1 and the remainder is 0. Now, it is not possible to divide 1 by 0. So, what we will do? We will write the answer from bottom to top. So, the binary equivalent of 17 is 1, 0, 0, 0, 1 base 2. So, this is the binary equivalent. Now, next we can learn how to convert decimal fractions to binary. How to convert decimal fractions to binary. Now see here, this is a decimal fraction. In order to convert a decimal number, we have to repeatedly divide that number by 2. Now, in order to convert a decimal fraction to binary, we have to repeatedly multiply that number by 2. Now see here, we will take the number that is 0.703125 and we have to multiply it by 2. then we will get the answer as 1.40625. Now see here, we will take this point part, that is 40625. Again, we have to multiply the point part, that is 40625 into 2. Then we will get the answer as 0.8125. Again, we can take this part, that is 8125. Then we'll write 0.8125 into 2. Then the answer will be 1.625. Again, we will take this point part. Actually, we have to do this multiplication continuously for 6-8 times. Then it will be too long. So you have to multiply 2 times or 3 times. That is enough. Just multiply twice or thrice. That's enough. So we'll take 0.625. Then we'll write 0.625 into 2. Then we'll get the answer as 0.25. Now we'll take 0.25 into 2. Then the answer is 0.5. Now we are multiplying 0.5 by 2. Then the answer is 1.0. Now see the decimal part, that is 0.0. Any number multiplied by 0, the result will be 0. So when we got 0 at the decimal part, we can stop multiplying. And sometimes when we are converting decimal to hexadecimal, decimal fractions to hexadecimal, we have to do the multiplication process and it will be difficult. So I think just multiply 3 times. That's enough. That is more convenient. Now we have to write the answer. So while we are writing the answer, we have to write the answer from top to bottom. We have to take the values before the decimal part and we have to write the answers from top to bottom. First we'll take 1 and we'll write 0.1. Next we'll take 0. We'll write 0. Next we'll take 1. We'll write 1. Again we'll take 0. We'll write the 0 here. Again we'll take 0. We'll write the 0 here. Then last 1. We'll write 1 here. Then we'll write base 2. So this is the binary equivalent of this decimal fraction. Now next question, 0.8125. We have to convert that into binary number. Again, we have to repeatedly multiply this number by 2. So we'll get 1.6250. We'll take the point part, that is 0.6250 into 2. We will get the answer as 1.250. Then again 0.250 into 2. We will get the answer as 0.50. We'll take that part. 0.50 into 2. We will get 1.00. Now we can write the answer from top to bottom. So first we will take the value 1. First we have to put the point 1. After that we have to write next one. Then 0. Then 1. And we have to write base 2. This is the answer. One more question we can try. That is 105.25. Now see here. Here you can see decimal part and fractional part. So we have to continuously divide the decimal part by 2 and we have to continuously multiply the fractional part by 2. So first we will take 105. We will divide 105 by 2. We will get the quotient as 52. We have to write down here and the remainder in the side. Again 52 is divided by 2. The quotient is 26 and the remainder is 0. Again it is divided by 2. The quotient is 13. The remainder is 0. Again 13 is divided by 2. The quotient is 6 and the remainder is 1. Again it is divided by 2. The quotient is 3 and the remainder is 0. Again it is divided by 2. The quotient is 1 and the remainder is 1. Now it is not possible to divide 1 by 2. So we got the decimal part. And we have to write the answer from bottom to top. Now next is the fractional part. So we'll take 0.25 into 2. 0.25 into 2, the answer is 0.50. Then 0.50 into 2, the answer is 1.00. So we got the fractional part also. We have to write the answer from top to bottom. Now we can write. So what is the binary value of 105? We will write first 1 here, next 1 here, then 0, then 1, then 0, again 0, then last 1. After that we have to put a point. Now we will write the fractional part of we will write the binary value of this fractional part. First we will write 0, 0, then next 1, and we will write base 2. So this is the binary equivalent of this decimal fraction. So in this way we can convert a decimal number to binary and decimal fraction to binary.